So this is going to be the final video installment that we have for this semester. And the last thing that we need to talk about is going to be the female reproductive system. So you should have your reproductive packet. We've already gone through the male reproductive system. And like I said, just moving on to the female side of things for right now. When you get to the section of the packet that deals with the female reproductive system, the one of the pictures that you have is a cross section of the female anatomy. So if you were to do a cross section cut and then look into the female body from the side, that's essentially what you would see looking at that picture. So we're going to spend some time talking about the internal anatomy and structures for the female body. So when you start at the top left, the first thing that you have identified there is the uterine tube. And the uterine tube is a structure that gets a lot of different names, and depending on which one your doctor is most comfortable with, is the one that you will probably hear. So uterine tube, oviducts, fallopian tubes, all of those terms could be used to refer to this particular structure here. And this is actually the tube that is going to take the egg and transport it from the ovary down to the uterus. Now, when you look at this, and we'll talk more about the ovary here in a second, but when you're looking at this from this particular vantage point, it does look like it's connected and that the uterine tube is just kind of attached to the ovary itself, and that's not the case. The fimbriae, the finger-like structures that you have at the end of the uterine tube, actually do cover the surface of the ovary, but it's not enclosed by any means. And so there is the potential that an egg could be released from the ovary and never ever make it into the uterine tube itself. But once that egg is released from the ovary, in theory, it's going to get drawn into the uterine tube, and then it's ultimately going to continue to travel and make its way to the uterus. Underneath that, we have the ovary. The ovary is going to be, like I said, the site of egg release. So right from birth, a female has all of the eggs that she will have for her entire lifetime. They're going to be housed in those ovaries, and they only go through development up to a certain stage. And then once the egg is getting ready to be released, at that point, it's going to continue to go through the maturation process, become fully developed, so that if it does become fertilized, it could result in a pregnancy. But going back to that fact that a female has all of the eggs that she will have for her lifetime from birth, then as we go through the aging process, when we get into those later years, so looking at, and I'm talking reproductive years, but when you get into 35, 40, because those eggs have been with us since birth, they do start to deteriorate, and there is a potential for more risk or complications with a pregnancy at that point, just for that reason. The ovary is also going to be the main site for your hormone production. So primarily when we look at estrogen, that is going to be the source of where that estrogen comes from, is from the ovary itself. Now, ovaries are going to work in alternating months. So you have a right and a left ovary, and 1 month the egg will be released from the right ovary, and the following month it will be released from the left ovary. And so they alternate back and forth, really only releasing an egg 6 times a year. It will also account for why some women will experience different symptoms with their cycle each month, because depending on the ovary that is releasing the egg can determine the symptoms that are associated with that. So 1 month the symptoms might not be that bad, might really not notice any changes, and another month it might be a lot of symptoms, a lot of cramping, a lot of pain and things like that. And that goes back to, again, that ovary that is releasing the egg that month. Continuing down the list, you have the uterus, and looking at the uterus in this particular picture, obviously it is a uterus that is not taking care of a pregnancy at this point. But one of the things that should jump out at you immediately is the thickness of the uterine walls. So if a woman was to become pregnant, at the point that labor would begin, you are going to have a series of muscles contractions that are going to force baby down and out of the body. And so that thick layer of muscle that you have throughout the uterus is going to help with that process, and it's necessary for that process. The arrangement of the muscles is varied. So you have some of the muscles that will run vertically, you have some that run horizontally, and you have some that run diagonally. And that's because implantation of the pregnancy can really happen anywhere in the uterus. And so to ensure that at the point of labor, baby is consistently getting pushed in the right direction, those muscles run in all different directions to get things going in the right direction. Then below that, you have the urinary bladder. And this again can explain why a female, especially later on in pregnancy, may have the sensation that she needs to use the restroom quite often when you put a full term pregnancy. So looking in the neighborhood of 7 or 8 pounds sitting on top of that bladder, it constricts it. And so it doesn't take the same amount of volume before the bladder gets that sensation that it's full and relays that information to the female. Under that, you have the symphysis pubis. So this is a cross section. When we've been talking about our skeleton and our bone structure, as part of the coxa is the pubis bone, and it is going to unite the two halves of the pelvis together. And what it does in this particular spot of the body is it's going to offer support to that internal female anatomy, especially during pregnancy when you have the additional weight of baby inside. It's going to help support all of those structures. So you can see, because of the location of that bone, the important part or the important role that it would play in making sure that all of those internal structures have just a little bit added support. Then below that, we have the urethra. And so the urethra is going to be the tube that is going to take urine from the body to the outside world. We've already covered this when we went through our excretory chapter, but just again, another look at it. The next one that you have down is the clitoris. The clitoris is essentially a bundle of nerves that you have in the female body, and it actually mimics very closely to what the penis does in the male body. So when it is stimulated, it will actually take on more blood volume than it normally would, and that additional blood volume combined with the collection of nerves bundled in that particular area will make it more sensitive. The next two that you have refer to the skin folds that you have in the female body. So you have the labia minor and the labia major. Sometimes minor and major will be used in place of those also. So again, another place where you have multiple terms to refer to one particular body part. So as I mentioned, these are the skin folds that you have. They are on the outside of the female body, and they are going to do a couple of different things. Number one, they're going to offer protection to the female body and just create a barrier. Because you do have openings to the outside world, you have the urethra, you also have the vaginal canal. And so those skin folds are going to make it just a little bit harder for bacteria and other things to easily get in and out. And they're also going to help hold moisture in this part of the body. And so they do have somewhat of a dual role. The minor skin folds, the smaller of the two, you can identify those because they will lack any hair. The major skin folds are going to be identifiable because they will be covered with hair. The next one that you have on that left-hand side refers to the vaginal orifice. This is just the opening that you would have into the vaginal canal. And so it is just that exterior portion or that very last portion of that vaginal area. If we go over to the right-hand side, looking at the top structure that you have there, the first one is the fimbriae. And I already touched on these very briefly when I was talking about the ovary and the uterine tube. So these are finger-like extensions that you have on the end of the uterine tube, and they will actually have this wave-like action so that when the egg is released from the ovary, because of their wave-like action, they help pull the egg into the right location. As I said earlier, it's not enclosed, so if you didn't have that extra pull, there would be more of a chance that that egg would float off into the wrong area and never make it to the uterine tubes, let alone the uterus. The next one that we have is the rectouterine pouch. Recto just tells you that it's positioned behind, and when you look at where this line is going to, you can see that it is referencing that area that you have tucked just behind the uterus. And it's a little space that is carved out between the uterus and the large intestine. So if you look just to the left, you can see the uterus, and if you look to the right, you can see the last section of the large intestine. So that area that's created from those two spots coming together is just known as the rectouterine pouch. There's no structure there. There's nothing that really happens there. It's just a space that's created. It also explains why, because of the close proximity of those two structures, after delivery, one of the things that they will want to monitor is that the large intestine is kind of up and working again. So they will listen for those internal sounds, check on bowel movements and things like that. Some places will automatically give a stool softener after labor and delivery just to help things start functioning normally again, because with the delivery of baby, there is also a lot of trauma that is placed on the surrounding structures, and that would include the large intestine as well. The next one that you have there is the fornix. Again, this is not an actual structure. It's more of a location or a pocket that is created because of the surrounding structures. Then you have the cervix, which is listed next. Now, the cervix is technically the bottom third of the uterus. So when you look at where that line is going, it kind of looks like it's just referencing that opening from the uterus into the vaginal canal, but it's actually going to be referencing that bottom third of the uterus. And this is what you would be checking and monitoring during labor and delivery, that has dilated to that 10 centimeters, and baby is ready to start moving forward. From there, you have the rectum, and this is just the final portion of the large intestine. We have a wayward line in there that's also pointing to the bladder. So the one that extends all the way over to the bladder, that should not be there. The rectum is just that angled line there. And then you have the vagina, or the birth canal. So this is the path that baby would need to travel during the process of labor and exiting from mom's body. And then the last one that we have on there is the anus, and this is where any solid waste would leave the body. Again, just kind of referencing all those structures that are in the immediate area, and those that, like I said earlier, could be potentially disrupted in their normal function just because of how traumatic labor can be. So the next slide that you want to look at is just titled ovaries. And again, it's hard to go through that first slide and not touch on some of the information about the ovary, but I wanted to come back and talk a little bit about that concept of the eggs. So the eggs are going to be housed in the ovary, and during the process of fetal development, initially there will be several million eggs that a female is going to start with. And then as they go through the developmental process, some of those eggs are going to be lost for a variety of reasons. So several million while we're going through fetal development. By the time that baby reaches full term and is ready to be delivered, that number is going to drop to 1 million. And then as they continue to go through growth and development, before they ever hit puberty, that number is again going to drop to roughly around 400,000 eggs. And obviously these are averages. From one person to the next, that would vary. So these are roundabout numbers. And then when a female is in her reproductive years, so from the time she enters puberty to the time that she would go into menopause, somewhere in the neighborhood of 400 to 500 of those eggs are going to be released. So while we start with quite a few, and that number continually drops throughout our lifetime, we far exceed the number that we would ever possibly use during those reproductive years. So only about 400 to 500 would ever be released from the ovaries and having a chance to become fertilized. So if you look at the next slide, that is called the process of ovulation. As I mentioned earlier, the eggs, while they are there in the female body, they are not fully developed, because you would not want them to be fully developed from the time you're a baby and then have to wait until the female hits puberty, and then even beyond that until she would potentially become pregnant. So there can be obviously a good span of years in there. And so the eggs are there, but they are not ready and fully developed until they actually go through the process of ovulation. So when you look at the far left, it talks about the primordial follicles and the primary follicles. And so the primordial follicle just indicates that it's a sex cell. And when it's in that stage, it is not fully developed, it's not fully matured at that point in time. And so once that particular egg is going to be the one that is released for that month, it will start a series of events to finish off the maturation process, go through the last part of meiosis, and become fully developed so that once it's released, it could potentially become fertilized. So those primordial areas, that's telling you that it is still in the developmental phase. And as it starts that transition, it talks about time. That time is just what it needs to finish off the process of meiosis. So as it transitions into the follicular cells and the primary oocyte, what is actually happening is that area that you have around the cell itself is going to provide it the nutrients and other materials that it needs to finish off that maturation process. So that transition is just continually finishing off development. And then we get to the point where the egg is actually going to rupture from the ovary itself. Now, some women can actually say that they feel this and they know the exact moment when this happens. Um, so that again is a personal thing that probably doesn't happen for every female, but some women do say that when that egg ruptures from the ovary, it is something that they can actually pinpoint and they know when it's happening. Now, once the egg ruptures from the ovary, it is then going to leave behind the corpus luteum, and that's basically a scar that you have within the ovary from where that egg ruptured and broke through or broke free. Over time, it will disintegrate and go away. So that's, again, just a time process of that material basically dissolving and being reabsorbed into the system. But once that egg cell has ruptured free, you can see the fimbriae around the ovary, and they are going to help pull that egg into the right direction. Now, with the egg cells, because they are going through meiosis, if you think about meiosis, we've talked about the two types of cell division. We have mitosis and meiosis. Mitosis is for your normal body cells. So anything that is not an egg cell or not a sperm cell is going to go through mitosis. The sperm and the egg are the only two that use meiosis. Now, at the end of mitosis, you have two brand new cells that are identical to each other. At the end of meiosis, you have four new cells, and they are genetically different because during meiosis, we have that crossing over where two chromosomes that are positioned side by side can flip flop and exchange out their genetic information, making them different than the parent. And this is vital to make sure that we as offspring don't look exactly like our parents. So crossing over happens. The process of meiosis involves two cell divisions. So we start with one cell, it divides, becomes two cells. Those two cells go through a second cell division, so those two become four. And at the end of meiosis, we have four cells that are genetically different from each other. Now, in the female body, it works a little bit different than in the male. As the sperm cells go through meiosis, at the end, those four cells are four viable sperm, meaning that if any one of them was introduced into the female body, they could potentially fertilize the egg and cause a pregnancy. Females doesn't work that way. So the egg cell will go through those two cell divisions. We'll end up with four cells at the end. But what happens is during the cell divisions, the egg cell does not divide equally. So during that first cell division, the one cell will divide into two, but one cell is overloaded with all the good stuff. It gets more cytoplasm, it gets the best of everything. And so you end up with this one really strong cell, and then you end up with this off cell that is known as a polar body. Those two cells will go through the second cell division, and the same thing happens again. That one really good cell will again divide, gets a majority of the good stuff, gets all the cytoplasm it needs, and the other cells are smaller. They don't have all the materials necessary to sustain life, and so they are referred to as polar bodies. They will disintegrate, be reabsorbed into the system. They never have the potential to become a pregnancy. Now, the reason that this is a good thing is because if we followed the same thing as sperm cells in the female body, and all 4 of our egg cells were viable at the end of meiosis, then every time we got pregnant, we would have quadruplets, potentially have quadruplets. Because if all 4 of those eggs went through meiosis and were viable egg cells, all 4 of them could be fertilized and result in a pregnancy. So the fact that 3 of them are polar bodies and that you have just that one good cell ensures or makes it more likely that you're only to have one child at a time. Now, twins. Twins can happen a couple of different ways. One is if you have identical twins, you had the fertilization of the egg, and after fertilization of the egg, every time that those cells split and become double, so 2 become 4, 4 become 8, 8 becomes 16, you have this ball of cells, but they actually break apart from each other. So every time they double in number, they break apart and then they come back together. And then they'll break apart again and they come back together. And so for the first part of development, that is just a process that the fertilized egg will go through. In identical twins, something will happen that prevents those eggs from coming back together. So they break apart, but they never come back together. So now you have these 2 individual bundles of cells that are doubling in number, and ultimately you get 2 developing embryos. In the case of fraternal twins, where they don't look alike, for some reason, mom released 2 eggs. Both of those eggs became fertilized by different sperm cell, and that's why you see 2 children that are very easy to tell apart. So in the release of eggs, there can be a variety of things that cause a doubling of eggs to be released. If mom is on some antibiotics, that can disrupt things and she will release more than 1 egg. You can have stress that can cause it. I already mentioned just any medication. I said antibiotics, but any medication can trigger that to happen. And the older that you get, the more likely you are to start releasing more than 1 egg at a time. So the next slide that we have just goes back to some of the internal structures that you have in the female body. And I do want to go back to the uterine tube very quickly. So with the uterine tube, that is actually where fertilization is going to take place. So when sperm is introduced to the body, it would be introduced into the vaginal canal. It actually has to make its way all the way through the uterus. Once it gets to the uterus, it's going to find its way into the uterine tube, and that's where the egg is, and that's where fertilization will take place. Once fertilization has happened, then the egg will continue to make its way down to the uterus, and that uterus with the blood lining, it will burrow into that blood lining and it will start the process of developing at that point. Now, a couple of things can happen. Number one, if fertilization takes place and the egg does not continue to make its way down the uterine tube, but yet implants in the uterine tube itself, it will start to grow and develop normally. Mom will get all the signals and signs that she is pregnant. But unfortunately, as that baby starts to grow and develop, the space is just not there in the uterine tube. And so it will get to a point where mom will start to experience a lot of pain because baby is surpassing the space it has in the uterine tube. And eventually, that's what we know as an ectopic pregnancy, and they are not viable pregnancies. So fertilization happens in that uterine tube, but we want baby to continue to make its way down to the uterus and implant in the uterus. The old wives' tale that you could tell if you were having a boy or girl based on where or how you were carrying has absolutely no relevance. Baby can implant absolutely anywhere in that uterus. So you have a blood lining throughout. Wherever baby lands is where they're going to develop. It has absolutely nothing to do with gender. The good thing about having fertilization take place in the uterine tube is because sometimes mom becomes pregnant and doesn't know that she is pregnant. And so it can take several days for that egg to travel from the uterine tube down into the uterus and implant. Until baby implants, it is not dependent on mom. So that's a very important key piece of information, because if mom doesn't know she's pregnant and she's putting things into her system that could be harmful to the baby, especially in those very early on days, then you have potential for risk there. But if it takes that baby several days to make its way from the uterine tube down to the uterus and actually implant, that reduces the amount of time between when mom became pregnant and when she actually knows that she's pregnant. And so if we can close that window of time, it reduces the chance that mom is going to do something or put something into her body that would be harmful to her unborn child before she even realizes that she's pregnant. So that's a very important part of the developmental process. The next slide that you have, it takes a look at the uterine tubes from a little bit different vantage point. You can see how the ovary into the fimbriae, and then how the egg would have to travel down to the uterus. You can also see the track that the sperm would have to take. So they're going to be introduced into the vagina, have to make their way up through the cervix, all the way up through the uterus into the tubes. And when sperm is introduced to the female body, you have a massive number, in the millions, of sperm that are introduced to the body. And part of the reason why we need so many is because, number one, you have sperm, which are the smallest cells in male or female. And because of their size, the distance that they have to travel to even find the egg is pretty great. And so some of them won't make the trip. They just won't have enough energy in order to make the trip. And then because there are two uterine tubes and the sperm have no idea which tube the egg is in, 50% of them are going to go the wrong direction. And so then you lose another large chunk of the sperm cell that were introduced to the female body. So that's why we need such a large number to ensure that pregnancy can happen, is just because of all the obstacles that it really takes to get to the egg and then be able to find it in the right location. So this picture was just to give you a little bit different vantage point of, like I said, the position of the ovary to the fimbriae, the uterine tube itself, and the track that both the egg and the sperm would need to take in order to meet up with each other. You can also very easily see that if you were to have an egg implant anywhere in that uterine tube, that there's just not enough space for baby to grow and develop there. So once you have fertilization take place, there are a series of hormones in the female body that are going to recognize that you have become pregnant and maintain that uterine lining throughout the pregnancy. Likewise, if you don't become pregnant and that signal is not given off that there's a pregnancy, hormones will fluctuate so that that blood lining is going to be shed at the end of a cycle. And for some people, that's 28 days. Some it's a little bit less, it's a little bit more. But the four main hormones that you have in the female body are LH, FSH, and then estrogen and progesterone. So LH is your luteinizing hormone, FSH is your follicle stimulating hormone, and then estrogen and progesterone. For part of your assignment, what I'm going to have you do is for those four hormones, luteinizing hormone, follicle stimulating hormone, estrogen, and progesterone. I want you to, number one, explain specifically what they do in the female body. So you will list them. You will explain what they do in the female body. And you will also explain when they're at their highest point during the monthly cycle and when they would drop. Okay. So you've got the four hormones. You're going to list those out. You're going to identify exactly what they do in the female body. And then the final piece to that is when they're at their highest and lowest throughout the month. Okay. You will have another piece to do, which I will post in Blackboard. It's a quick true and false, and it's not something that you're going to have to look up each one of the answers for. I want you to keep it as a true, false, your gut reaction. So you'll read the description. You will simply decide if you think that is a true statement or a false statement. It is not going to be a percentage grade. So I'm not grading it based on wrong and right answers. I am basing it on a participation grade. Now, as I say that, I still want you to give it a little bit of thought and take some time in doing it. So read the descriptions, give your best honest answer of what you think it is, if it's a true statement or if it is a false statement, and be ready to turn that in as well. So you'll have two things that you'll turn in and bring with you on the final. For the final exam, you are going to have your bone test. It's been kind of a long time coming. This is the one you were supposed to do in December. So you will have sheets of bones laid out. You will have a word bank to use, and you will have to simply identify the bones that are laid out for you. The pictures will not be identical to the ones that I posted in class, and I've kind of told you guys that all throughout the year, just so that you are aware of that. But obviously, the bones are all the same, no matter if you're looking at a carbon copy picture or one that is slightly different. If you have any questions between now and the final exam, please email me and let me know, and I will get back to you with your questions.